Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we have discussed how will you distinguish the following pair by IR spectroscopy. Generally we are talking about the organic chemistry. So IR spectroscopy we have discussed all these points in detail, how to solve problem based on it, that is also we have discussed. Now let us see some of the what we can call it as an important question, probable question may appear in an exam. So how you can describe it or how you can explain it, that way we are going to discuss. Let's see here, for 1 mark question, answer the following. 1 mark each. Calculate the fundamental mode of vibration for C2H5OH. That type of the problem we already discussed. Let's see, suppose as a calculate the fundamental here, calculate the fundamental mode of vibration for C2H5OH, that is the ethanol, as you know that. And this 1 mark question always appear in the exam. If you know how, do you know how to solve it? We already discussed this, how to calculate the fundamental mode of vibration of different molecules. For solving such type of the problem, you require, I already explained that one, there are the 2 formulas. Depending upon the geometry of the molecule, you have to decide. If the geometry of the molecule is a linear, then you can use the formula for the calculation of fundamental mode of vibration will be 3n minus 5, where n indicate as a number of atom present in the molecule, total number of atom involved in the molecule, that you have to count and put there, and you can solve it. Whatever answer comes, that will be the fundamental mode of vibration for those molecules. And if you see here, C2H5OH is nothing but as a ethanol. Sometime it is written as a ethanol, or the molecular formula is given C2H5OH, it is nothing but as a ethanol. Here you know that the structure of ethanol will be like this. We are generally writing CH3, CH2 and OH. Now tell me whether this molecule is a linear, what type of the geometry that molecule has, whether it has linear geometry or it has non-linear geometry. If the molecule has linear geometry, linear molecule, you can use the formula 3n minus 5. If the geometry of that molecule is a non-linear molecule, you can use the formula 3n minus 6, where n indicates as a number of atom involved in that molecule. So now tell me, while answering this, tell me whether this ethanol is geometry of that ethanol, whether it is a linear or non-linear. Linear means a straight line, even though I am written as a molecule like this, but it is not the straight, whose angle should be 180 degree. That is a linear molecule. If you see here, it is not the linear molecule. The geometry of this ethanol will be non-linear, and therefore you should use the formula 3n minus 6. Here you just write it. Ethanol is a non-linear molecule. Ethanol is non-linear molecule, and therefore fundamental mode of vibration, number of fundamental mode of vibration will be 3n minus 6, where n is equal to, n is nothing but as a number of atom present in the molecule, where n is a molecule, where n is a number of atom present in the molecule, and we know that C2H5OH, count the number of atom, carbon atom to hydrogen atom are 6 and 1 is the oxygen, so total becomes 6, 7, 8 and 9, right? 9 atom are involved in ethanol, therefore you can substitute there 3 into 9 minus 6. So 9 into 3 is a 27 minus 6, so 21 is a fundamental mode of vibration observed for ethanol molecule. So this is the way of solving the problem based on this. If you solve in this systematic way, you will get as a 1 mark. So that's very easy. Here for benzene is given molecular formula C6H6, as we know that. CO2 molecule, which is a linear, water molecule, ethane molecule, ammonia molecule, nitrous oxide. So these are some of the example, and from that we can calculate it, and we already learned. So let us see another one. Calculate the fundamental mode of vibration for chloroform. Let's see here chloroform. Calculate the fundamental mode of vibration for chloroform. Chloroform. And as we know that now here once again you must know the structure of the chloroform. The organic compound, which is very common compound, and students should know the structure of these common compounds. Chloroform, sometimes is a name is written in word, and sometimes the chemical formulas are given. If chemical formulas are given, it is very easy. You just count the number of atom involved in it. That is very easy. But chloroform is given, that chemical formula is not given, it is written in the word. So here you have to think, you have to recall what type of the chemical formula of chloroform. So many of you maybe as a 99% of you might be knowing the structure of chloroform will be this one, CHCl3. This is the formula for chloroform. Now the second question arises whether it is a linear molecule, whether this chloroform has linear geometry or non-linear geometry, because depending upon the geometry, if you identify geometry of that molecule perfectly, and then you will get as a mark whatever mark provided to that question. So here chloroform, once again it is a non-linear geometry, and therefore once again you can use this formula. So while calculating as a fundamental mode of vibration, use a 3n-6, because chloroform is a non-linear molecule, and therefore for the calculation of this fundamental mode of vibration will be 3n-6. Therefore 3, so count the number of atom involved for the formation of chloroform will be 2 carbon atom, 1 hydrogen, here only 1 carbon atom, 3 chlorine atom and 1 hydrogen atom, total becomes as a 5. So substitute here 5 minus 6 and it will get 3 into 5 becomes as a 15 minus 6. So 15 minus 6 remains is a 9. So 9 will be the fundamental mode of vibration for this molecule. Then sometime is written, calculate the fundamental mode of vibration for BF3. Once again, BF3 means boron trifluoride, sometime may be written as a boron trifluoride, which is an inorganic compound actually. But here, what is the aim? To calculate the fundamental mode of vibration. The molecule may be organic or inorganic, doesn't matter. What is matter? Only you must know the geometry of that molecule. BF3, once again it is a non-linear molecule, and the number of atom you can count very easily. 3 fluorine atom and 1 boron atom, total becomes as a 4. So substitute the value here. Once again BF3 is non-linear molecule. BF3 is a non-linear molecule. So fundamental mode of vibration is equal to 3n-6, and therefore 3n into 4 minus 6. So 12 minus 6 remains as a 6. 6 will be the fundamental mode of vibration, it is a fundamental mode of vibration. You can calculate in this way. So there are 6 number of fundamental mode of vibration is present. So in this way we can easily find out what type of the fundamental mode of vibrations are present there. So now next one, the question, how will you distinguish the following pairs by IR spectroscopy? And there are a number of pairs are given, such as CH3CH2 C triple bond N and CH3CH2 C triple bond CH. Now one more another question generally there, how will you calculate the fundamental mode of vibration for fundamental mode of that question is we already covered here. Next question may be, how will you distinguish the following pairs by IR spectroscopy? How will you distinguish the following pairs by IR spectroscopy? How will you distinguish the following pairs by IR spectroscopy? So here, see, the pairs are given like this. Number 1, here CS3, then CH2, C triple bond N, and another one CS3, CH2, C triple bond C and H. That is, a pair is given. So how do you solve this? I already explained this type of the question at the beginning in a previous lectures. Now look at here, what are the functional group? Because IR known for the functional group. IR spectroscopy is very well known. It is corresponding to the functional group. It providing information about the functional group. So now here carbon-carbon triple bond is here. The IR absorption band appear around is 2200 per centimeter. Here triple bond also is there, 2150, or maybe as a near about exactly identical. It doesn't make any difference, but this is not the prominent peak observed in both the structure. If you compare two spectra, you will find both the spectra will give recognizable peak around 2200 per centimeter to 2150 per centimeter. This is a clear-cut indication for the presence of carbon-carbon triple bond in the organic compound. In addition to, in the second one, it will give one very typical peak around 3300 per centimeter. The IR absorption band around 3300 per centimeter due to the terminal alkyne. That is a characteristic of that band, and which is absent in the first structure. So in this way, the IR spectrum of first structure will give only one signal, recognizable signal, around 2200 per centimeter. But in the second structure, it will give two recognizable peak, one around 2150 per centimeter and another around 3300 per centimeter. So these are the two peaks are appeared, and that's why in this way we can easily, this first structure gives one signal, whereas second structure will provide two prominent peak, and from that we can easily distinguish these two structures from each other. Another structure may be as a, let us see one of the simplest one, second one, which is this one, CS3, then CH2, C double bond O, H, and another one will be this one, CS3, C double bond O, and the CS. So simple structure. One is a propanaldehyde and second one is acetophenone, we know that. Now the question, how will you distinguish the following pair by IR spectroscopy? So here one which we have explained over here, now is the second one. In the second you will see here carbon-carbon double bonds are there. Here also has a carbon-oxygen double bond carbonyl, so it is around 1720 per centimeter and which is around 1715 per centimeter. So both the compound containing as a common functional group which is a carbonyl group and the stretching frequency appear around 1720 or 1715 per centimeter, that is a normal value of that carbonyl group and which is generally shown by aldehyde and the ketone. But how do you separate, how do you identify, how do you distinguish the one additional prominent peak or the notable peak appear here due to the CH stretching which is near about 2700 to 2900 per centimeter. 2700 to 2900 per centimeter, that is the additional peak appear. These two peaks 1720 and 2000 to 2900 per centimeter clearly suggests that there is a aldehyde group is present and aldehyde group is always present at the end of the organic compound. But in the second structure only one peak is appear which is around 1715 per centimeter due to the carbonyl group, and that carbonyl group 1715 per centimeter is there. That's why this will give the two peak, this structure will give only one peak. So in this way we can easily distinguish these two structures from each other. Now I think these are the enough example of these type of the problems. Then there may be explain the following, maybe for 2 or 3 mark, like what are the application of IR spectroscopy. You just give the list of application of IR spectroscopy. I think we have discussed 3 or 4 application of IR spectroscopy, such as determination of structure of organic compound with the help of following point we have discussed. Functional group, second one will be the functional group, fingerprint region and the aromatic region. With respect to these 3 points we have discussed this point. And second, study of progress of chemical reaction. Third one, hydrogen bonding. Fourth one, ring structures. And fourth one is the detection of impurity. These are the some of the application we have discussed in detail. So I think with this we have completed as a chapter number 6, which is IR spectroscopy. In the next lecture we are going to discuss very important and the last chapter of this semester we can say here of the spectroscopy, that is a PMR spectroscopy. PMR spectroscopy means proton magnetic resonance spectroscopy. How it is more important than these two, and at the finally by combining all these three spectroscopy together, we will solve the number of problem based on those three spectroscopy. I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.